Okay, so here are some optimizations with radix map. There's a big disadvantage. There's a big disadvantage to this implementation because it has to process the entire array 4 times on every insertion. It does it so fast, but it better be if you could limit the amount of sorting by the size of what we need to sort. There are two ways you can improve the implementation. Use a binary search to find the minimum position for the new element, then only sort from there to the end. You can find the minimum, put the new element on the end, and then sort from the minimum on. This will cut your sort space down considerably most of the time. Okay, and the minimum position. Okay, let's try that. Okay, so we have this. Go in here, see GitHub, then see the hardware, then Rix map and sort. Map and sort, and let's open up Vision PC. Okay, so in the radix map sort function, okay, right, I have to limit let me add radix map radix sort optimization. Okay, radix map. Okay, so first I have to find the minimum position of the element, right? So how does it sort right now? Sort right from source content of 0.raw, right? Okay, so it starts from 0, right? This it starts from 0. Okay, wait, so we have this contents rme contents me contents. This is max to size of, so I just need to change this here, right? Okay. So where is my radix map find, right? Okay, and I can make radix map find minimum, right? I can make a function radix map find minimum, right? And it takes a key and a value. Takes a key and a value, so it will take the radix map, then a key and a value. uh, Value, I don't think I need the value. I just need huh, the key, right, to find, right. Okay, so though I have to return, this function will find the minimum limit okay, right. So hold up, the minimum position of the element, just the minimum position, so find element that should, right, okay, so we find the position of the element that comes just before the uh, that comes just before the uh, what is find the position of the element that comes just before the position of the new element, right. Let me like see if I have this array, right, 1, say 3, then we have 5, then we have 6, then we have okay, let me get rid of 6, let's put 7, 5 and 9, right. Now I want to find possible position of new element 6, right. So I'll apply a binary search, right. Apply a binary search, so first it will go 0, 1, 2, 3, 4. Okay, so first it will check the mid, right, which is 0 plus 4 by 2, which is 2. So is, let's say, call this array of mid equals to our new element. So we go no, then we update the low, right, we update the low. So low equals mid plus 1. Right, so this is 3. Right, say 3 and 4. Okay, we come on to 2, 3 and 4. Okay, so base condition in radix find is while low is less than or equal to high. If low becomes greater than, that is the point, right? Right, okay, so we go low equals mid plus 1, then we say mid equals, which is equals to mid plus 1, 2 plus 1 is 3, okay, right, and 6 is to be inserted here. Minimum position of the element. Mid is equals to 3 plus 4 by 2, which is 7 by 2, which is 3. We floor it. Okay, so now if array of mid equal to 6, no, it is actually smaller, right? So then we update high update high, so high equals to mid minus 1, right? So high equals mid minus 1, so high is mid is currently 3, 3 minus 1 is 2, right, is 2, and low is 3. Right, we update high. Okay, mid is 3, low is 3, and high is 2. So condition fails here. Condition fails. Okay, so at the point when the condition fails, I should ask if the condition fails. Right, the condition fails, I want to check, right? I say if low is less than h, right, then we return low, else we return high, right? If low is less than h, return high. So in this case we will return high, which is our minimum position. Okay, so let me try and insert another case. Let me try. Right, okay, great. Okay, and we have this part. So let me so I will, in this case, this is my minimum, so I will go from minimum to the end. And then, okay, so let me try another case. Let's say I want to add 2 here, right? I um, want to add 2, so we'll apply binary search. Binary search, right? Pillar mid equals 2, so a of mid is not equal to 2, right? Because a of mid is 5, so it is less than, right? So we will update high. Now high equals mid minus 1, that is 1. Then we check again, and mid equals 0 plus 1. Okay, so mid is equals to, this will be high is 1, low is 0, so 0 plus 1 by 2, 1 by 2. What is 1 by 2? Is it 0? 1 by 2 will be 0.5, so say mid is 0. 1 by 2, which is 0. Okay, then we calculate is wait. Okay, so mid is half, 0 plus 1 by 2 is 0. Then we say mid is not, because 0 is not equal to, it is actually greater, so we update low. Low is now mid plus 1, which is 0 plus 1 is 1. So mid of 1 is not equal to 2. 3 is greater, so we reduce high. High equals mid minus 1, therefore high is 0. And now low is actually greater than high. This condition, so we just this, which will provide us with minimum position. Alright, so let me say find min, and I'll update it to add. Okay. This function will find the minimum position in the minimum. Let's find the element such that it is just smaller than, element will find the, this function will find the position of the element such that it is just smaller the element we wish to add to the map, right? Okay, we will check map should not be equal to null, error, invalid radix map, right? Okay, nobody checks that, right? Okay. So we return -1. Then we have we will start a loop Do I need anything else? Yeah, I guess I need a low and a high. Yeah, low and a high. Okay, so int low equals 0 and int high equals map of end or end, right? End minus 1. Okay, end minus 1. And then since and stores the value just past the last element. Okay, and then I will also have a int middle equals 0. I'll go while true, right? While true, we'll first calculate middle equals low plus high minus low by 2. Right, okay. Then I'll check if if map of content, right? Okay, data contents. Okay, so we take a reference as well. Int middle. Okay, it is defined inside, so I'll also define it inside. We don't need. And our m element data equals map content, right? Content, so okay, so we go int middle equals this, and then we will check do we check the condition first? Yeah, we first check the condition. Check the base case. If low is less than equal to if low is greater than high, then what we will do is return low is less than high, then we return low, else we return high. Okay. Then we calculate middle, right? Then we'll go middle. Then we want to check if to find, right, if data of middle, what will this fetch me? Will this fetch me? Okay, so we go key equals data middle dot data dot key. Okay, right, and I have to provide the key of the element here. Key to add. Okay, so I also hit the middle and get the key corresponding to it, right? So I will go and 32 tail key equals data of middle dot data dot key, right? Because data of this will give me the elements here. This is an array, and then within this we have a data, and then we want the key. Okay, key if data. Okay, we say if key if current or data at middle, right? Key at middle. If key at middle if key at middle is less than the key to add. If this is the case, we update high. Then high equals middle minus 1. And else if, right, we put it in a else if clause. Else if, okay. Else if key is greater than key to add, then we will update low equals to middle plus 1. Then it goes again and it checks the condition if low is greater than high. If low becomes greater than high, then we do this, right? Then if to find key is less, like if the key, if the middle is greater, middle key is greater, then we update the low. If the middle is smaller, the middle element is smaller, then it should be, so we will update the low. Okay, so radix map find, and this is radix map find min key to add, right? Then we go to sort here. We go int min key equals source temp and add. Okay, so when we radix map add and it radix sort, right, it sorts the URM element, we add the element at the end, and for sorting for sorting purposes I should provide the 32 the key to add, right? I find the key to add, or I can just pass the element itself, but the element is big, right? RME element, RME element data map content element. It should be a pointer, I think. Dot data equals to dot key equals key, and then value. Okay, so I have key to add, key and value. So we check the and should be, and plus 1 should be less than map max, and then element dot data dot key dot value. Okay, first, okay, let's forget about this. Let me just check. Then we have this. Okay, let's test this function. Static int find sort map create. Let me make a function static int make random char test operations static char, yeah, okay, static char style test find min, and it takes nothing. Let me create a new map, right? Radix map. Let's create a new map. Map equals, but still, see, I I don't get that this is a static element, right? This element is static, and yet if we add element to the end of the map, and yet it can house. Oh, okay, it just copies the values of that element, right? Because the memory is already there. Okay, so even though the element we declare here is static. However, since we know that we cannot refer to the local variables outside of the function, then how can we add this element into an entity such as map that whose scope exists outside of the function. So let's say answer. The element is static in nature within the function. We are not concerned with actually adding the element itself, but the value that it holds, as the memory for the element is already allocated within the map. We can simply overwrite the struct rm element at the new position with the statically declared element. This is equivalent to let's say this is equivalent to map contents map and plus plus dot data, right, dot data equals, you can say dot k equals k and dot value equals value. Right, okay, so create a map. How can we create a map? Create max. Okay, there we go. Edit maps, create the max size of, I'll give it 10. And we check, right, we check or musert, right, we musert. Nav is not equal to null, error, fail to create map, fail to create edX map. Okay, then I wish 2, though I will add, okay, find I equals 0, I less than 10, I less than 10, yeah, okay, I will start with 1, then I equals I plus 2, and we will add, so it will add 5 elements, right? Radix map add this is key and value. Okay, I can have same value, it doesn't matter. Okay, so I will add to map, the key is I and the value is, let's say 2, right? Okay, we add that, search, find, check order, make random, then we sort the map, why do we sort the map? I don't really understand why do we sort the map when it automatically sorts the map for us. If I remove the sorting step, will it still work? Subdirectory P already exists. Make clean W. Make okay, so I just need to make clean W. Make right, okay, well, true undeclared 95 radix map dot c. Let me add hash include std pool.h. Okay. Okay. Int radix map, but argument is int type error. Oh, ready map 100 radix map dot c 100 radix map test dot c, right? Test dot c at 100 radix map, but yeah. Didn't I do that? Directory is not empty. Yeah. Build. Right, so it still works, right? Warning test defined but not used, that's okay. Warning, okay, yeah, so actually we didn't need to sort it manually, right? Check if the order of the map is maintained, right? Okay. Add elements and sort them automatically. Okay. In addition, we are also checking the delete functionality. Okay, map destroy. Okay, so we go with this radix map dot add, so it should have been sorted, and then I will simply radix map underscore destroy map, deallocate the map, and then I wish to find, like say I wish to find, where is the function, find min, key to add. Okay, radix map find min. Sorry, okay. So int min position equals to radix map find min in the map and key is 6. Right. Test operations, and then we go mu assert, not assert. Is there a function to is this should be a macro to run test. No, there's no macro such as that. Run test and assert. Okay, assert. So I will simply use log info. Right. Okay. So we'll go log info. Then pose of element less than 6 is echo and pose, and then I need to call this test. We have test find min. Failed to create radix map. -1. Okay, error. Failed to create radix map. Radix map create. Why? Failed to create the map. Radix map underscore create, right? Size to max. Approve a size. Then what happened? Info in position of test run 1. Okay, running. Test is find min pose of element less than 6 is -1. So how did it log mu assert let me put a check and then error return, but it just I'll define my error section, right? Test run. In position of element less than 6 is -1. Error failed to create. My sitemap should not be equal to null, right? So that's what I did. Let me assert error failed to create map. It says failed to create map, radix map. I don't radix map. You didn't declare any map beforehand, right? Radix map, test operations, test find min. Says failed to create radix map. I assert this, right? Failed error failed to create. Failed to create. It's failed to create radix map. Error failed to create radix map. Failed to create radix map. Okay, so I said that it should be null. Then it throws this error. Failed to create. Okay, error failed to create radix map. Let's see. Error, right? This is this mu assert? Okay. And failed. And then it shows me this error. Okay. Make says failed. Error failed to create radix map. I don't get it. Let me search, right? Okay, so result equals name. So mu assert test log error return message. Where is message? Char message equals null. mu sweet start. Okay, this message is null. Then when you mu assert log error and it returns message, mu assert returns message. So actually I don't know why would you do that, right? Signed int size g, yeah, operations create size 100. Okay, it can create size 100 and it doesn't fail, but let me assert map should not be map find min radix map find min. Key to add map. Failed. Error is failed to create radix map. Okay. So failed to create radix map. Test when find. Okay. If I go test operations. All test passed. Huh. Creates a map of size 100. And this is okay. But when I try to create a map, make random, literally adds key and I, right? One, three. Wait. Oh, sorry. Test find min. Right? Static get test check. mu search and log info. Let me go mu assert min position should be equal to what had I calculated, and position should be 2. Should be 2. Should not be now. If it is 2, then it's okay. If it is not 2, then test operations. Let me set error may undeclared first use of this function. And you assert, are you right? I'm just using it here. Message, log error message. Okay, maybe I cannot do that. It don't take variable arguments. So wrong position of the minimum pause. Map is full. Failed. Map is full. Create 5. Okay. So yeah, right. Map is full. Failed. E dot. Failed. What is it printing? I don't amuse it. Wrong position. Test find min. And min pause equals radix map find map 6. Min position should. What is this? And failed. Okay, so something has happened. Let me set min pause. This map should not be equal to null. Okay, I say that this should be equal to 2. Okay, make clean w and make wrong position of the min pause. And can I print log info min pause is min pause, just simply returns, right? Yeah. Position of the min pause is -1. Okay, and what is the case when it returns -1? Okay, check map should not be equal to null. Map contents error. Okay, so map is not valid. It's returning -1. What is provide the key, right? Find how much time. Oh shit, okay. Wrong position. Okay, it's still giving me -1. Okay, forget about this. Right. While true. If low is greater than high, well then it doesn't matter because it will always be high. If low becomes greater than high, checks the base case. Well, okay, low is less than equal to high, right? And in the end I will simply return high. High minus low by 2. If key at middle, right, is less than key to add, right? If we say, what is this? 2. 5 is 5 is less than 6, right? So we update low. Okay, that is fine. If this key at the middle is less than, right, so we update low. Okay, so I have mixed up the conditions low +1, and if the key is greater then it will be -1. Okay, so let's try and clear, then make clean W and then make it again. Okay, failed. Okay, so test run is this. In position is 2. Okay, info, and it says it has failed, but on what basis? Wrong position of the min pos? No. Failed to create radix map. I don't understand. See, it is correct, right? The min position should be 2. Let me just go with 6. I don't know. I'm just trying. Something should work. Log info, right? Then we go mu assert min position should be. I assert that this is true. This expression should be true. If it is not, then we say wrong position. Right, min position is 2, which is correct. Defined but not used. Control reaches end of non-void function. Saying this. Okay. Okay, that's why. Okay, that is because it holds some temporary, I think. So if it reaches the end, it should message char star. Okay, that is all my fault. Yeah, right. Okay, make clean w and then we make, and it says, yeah, test passed. Position. Right. So that was all my fault. Forgot to return null. It should return null. Don't forget this, else it will throw random values. Right. Okay. So this is correct. And all test passed. Yes. Okay. Nice. So it can identify these values. Then high, since this will contain the value of the data, just since this will contain the value of the data just before what contain value of the data just before this will contain the position of the element smaller of the key smaller than the one we wish to add. Right. Yeah. So that is it. Okay, what happens in case of 0? If say I want to add a 0 here, what happens then? Should I make it wide? Yeah. Okay. Let's say I want to add a say I want to add 0, then what happens? Let me take a look. So we'll go with our key is 0. So we will start with half, right? First, mid equals 2 and 0 is less than 5. So we update high. Then high equals mid minus 1, which is 1. And we again check 0 plus then we have 0 plus 1 by 2, which is 0 again. So mid equals 0 now, and 0 at 0 index we have 1 and 1, and 0 is still less than 1. So we update high again, right? 3. Okay, then high equals high equals mid minus 1. So mid is 0, 0 minus 1 is minus 1. At this point the condition fails. Okay, so I will just have to check let's put high equals if high less than 0, right, then return 0. If high is less than 0, then return 0, else return high, right? To add smaller than the one we wish to add. Okay, so let me just 0 and this is 0. So let me do a quick test. Clear W make, and okay, all tests passed. Okay, have I not provided this condition, right? If I just go return high, then it would have been minus 1, and let me, yeah, it would have been minus 1. So that's that. Okay, also minimum element, right? And what if, okay, 0 minus 1, so I have provided this, but what if there is like, and say I want to add 10, then what do we do? Okay, want to add 10, then what can we do, right? What can we do? Okay, so I want to add 10, then what can I actually do is what can I actually do? So we'll start at the middle, right? Okay, mid equals 2 and 10 is basically greater than 5, so we update low. Low is mid plus 1, so now low is 3. low is 3. Then we go high is 4, 3 plus 4, then mid equals 3 plus 4, 4 by 2, 3 plus 4 is 1, 2, which is still 3, right? So mid is 3, 3, 7, and 10 is still greater than 7. So we update mid low again. Then low equals low equals mid plus 1, 3 plus 1, which is 4. Right, yeah, it was still okay. So 4 now. Mid equals 4, so we have 10 is still greater than 9, so we update low equals 5, but now low is greater than, and so we return just 4, which is actually, yeah, okay, so this is correct. Just I have to handle a case where if we wish to, okay, I should also check that it does not break any other of my positions, right? Right, okay, so it doesn't. Also handle a case where if we wish to add an element which is smaller than the element at 0th index, then the high would become less than 0, which is invalid. Hence, if so is the case, we simply return 0, depicting the simply return 0. Okay, yeah, so let's turn it to static int, and I don't have to do this anymore, and then I will go sort, right? Redux map sort, Redux map add key, right? So I think sort should take on Redux map sort, maybe we'll keep it static void Redux map sort, and we get rid of this. We copy this algorithm since it is being called internally. Fine, okay, and I can add 30t key to add, and we will go with, I think it should return a unsigned 32, right? And okay, then we go with 32 minimum position equals Yeah, but um right, this would break because it uses sorting both ways. Right. I cannot. It's my find to find. Limit. Like I can provide the limit here. Source and temp and source. Content of 0. Right. It starts from the source 64. It takes the raw. I think it takes the raw content. 64. Then right. Okay, so I think I will put my brains into it later. But for the time being, I just have to make sure that this all works. Both tests work right. Right. Yeah. Index map starting and find men, and we have data middle check add index map sort. If I could tell it, or we'll have to use a flag. Right, but that is problem for next time. Let's call both of the functions. Test find and we'll run test. Okay, how does it know how many? Because it runs result. Yeah, see, running. Failed. All test passed. Okay, see, mu run test, message run test plus return message. Test run plus. Does it define test run? And test name. Define and test name. Debugger result 0. Printf test run equals test run 1. Then value of test, and if a message equals test. Okay, run. So starts, it calls, okay, because it calls it 2 times. See, first of all, it will call message equals test run if message, return message. So we run test, that's first one. All test. Okay, it goes inside and then call these functions. That's clever. So we will test operations. So let me just make clean w clear and make. Okay. Expansion and test, all test. Redix map find. Oh shit. Okay. So my bad. 32. Redix map find. And that's all right. Yep. Okay. Test run 2. All test passed, right? Okay, so we're making W and exit. Now maybe save session. PC save, yes. Okay.